The Department of Defense's commitment to net zero waste, water, and energy at their installations can benefit greatly from technologies that turn waste from environmental liabilities into value-added resources. Mr. Sewer is a novel system that synergistically integrates wastewater treatment and bioenergy production. It has been demonstrated to overcome key limitations with current wastewater treatment systems while yielding a sustainable, on-base source of bioenergy and treated water suitable for reuse. Defense installations face three key resource limitations that are addressed by the Mr. Sewer Environment Enhancing Energy System. First, the bioenergy supply. Second, wastewater disposal. And third, non-potable water supply applications. Mr. Sewer integrates solar-powered algal wastewater treatment technology with hydrothermal conversion processes to efficiently capture and convert wet organic waste into valuable bioenergy products, either biocrude oil or biogas, all with a net zero input of energy. In fact, an optimized system for Mr. Sewer can output 3 to even 10 times the energy content in the wastewater. This amplification of bioenergy is made possible by the powerful concept of multi-cycle nutrient reuse, a patent-pending feature at the center of the Mr. Sewer system. This novel approach maximizes photosynthetic capture of solar energy into wastewater bioreactors that grow both algae and bacteria as they remove wastewater pollutants. The Mr. Sewer system begins like a conventional wastewater treatment plant with primary clarification to separate the concentrated solids from the dilute wastewater liquids. The solids fraction is routed directly to hydrothermal conversion, and there it is turned into either bio-oil or biogas. This conversion process also makes a nutrient-rich aqueous product that is combined with the original wastewater liquids and fed into a mixed algal cultivation bioreactor. This bioreactor process also takes in sunlight energy and CO2 from the atmosphere and grows both algae and bacteria that uptake the major pollutants in wastewater. Subsequently, a secondary clarifier separates the mixed biomass from the treated water, which then can be reused in non-potable applications. The harvested biomass is routed back to the hydrothermal process to create more bioenergy products, and that re-releases much of the nutrient content so it can be used to grow another round of algal biomass. As a result of this multi-cycle nutrient reuse, the biomass cultivated in the system increases significantly, and so does the amount of bioenergy products. Our past research has shown that if this novel approach were applied with all current U.S. wastewater streams, it could produce enough bioenergy to replace all U.S. petroleum imports. The Mr. Sewer system can be applied with any source of organic waste, including sewage from a city or army base, food waste, manure, landscape trimmings, plastics, and even paper waste, which is the largest fraction of municipal solid waste. It can replace or augment existing wastewater treatment facilities, resulting in reduced treatment cost, reduced carbon footprint, and improved effluent water quality, all of which can facilitate water reuse and help meet the requirements of Executive Order 13693. Currently, the Department of Defense pays for treatment and disposal of waste at fixed installations in order to reduce environmental impacts. Mr. Sewer dramatically reduces disposal costs while turning a free energy source into carbon-neutral biofuels and mitigating security threats. A prototype commercial scale plant with a capacity of 10 tons per day has been developed at the Environment Enhancing Energy Labs at the University of Illinois. This prototype system has been successfully tested with food processing waste and swine manure, and we are currently developing R&D partnerships with other organic waste producers to confirm the feasibility and key design parameters for their applications. The prototype system is designed to be mobile and fits inside a typical shipping container. This facilitates on-site demonstration testing and eventually deployment in a variety of both military and civilian applications, including disaster response scenarios. Depending on the user preferences, the hydrothermal conversion process can be designed to either produce biogas or biocrude oil. The biogas is predominantly methane and hydrogen and can be burned in conventional boilers or generators to produce both heat and electrical power. The biocrude oil from hydrothermal liquefaction can be used as a replacement for crude petroleum. It can be refined into the wide range of renewable biochemicals currently made from petroleum. Our ongoing research is focused on simple distillation refining methods to produce 2 light fractions targeting biofuel blends in the range of diesel and jet fuel. The heavier oil fraction has been tested with commercial partners for use as an asphalt binder. This has been successfully used in a test patch of highway outside St. Louis, Missouri since 2012. As a result of the powerful multi-cycle nutrient reuse feature and the resulting amplification of wastewater biomass, our research has shown that applying this approach to all U.S. wastewater streams could produce enough bioenergy to replace all U.S. petroleum imports and achieve a secure and sustainable energy future.